question for Mine. It is. I got the impression from your presentation that our grey water and treated grey water can be, you can use it as drinking water, you can drink it, if I look at the numbers. So I would like to invite you to use your analysis on the data once on our grey water to see where we end up, because I
That's
think
an
that could give
interesting
an
exercise.
result.
Yeah, yeah. For the chemical side then.
From the yeah, of course, yeah.
Microbiology, I don't have a...
And if I'm allowed, can I ask also a question to Bas? This QSAR approach, I'm not sure, but what we would be interested in is to have a partial degradation of the compounds and then followed by biodegradation. In general, that is much cheaper. Could you also predict for UV or for ozone or whatever advanced oxidation process that you get a primary degradation, so only opening up the rings, etc., and then make a more biodegradable compound out of it? Could you use your QSAR system for that?
Yeah, that's difficult because then you use the QSAR to predict which kind of byproducts are formed. So that's kind of difficult. I think that's also another approach than we used here. But maybe in principle that there are, but yeah, it's another approach. But I think it's quite difficult. But maybe Pim has also some experience on that.
Yeah, maybe. What you obviously need is a set of empirical data by which you can actually try to derive the kind of relationship. So if there is a certain amount of empirical data available for that first step, then I think you would be on stable feet. As long as you don't have empirical data for that primary step, then I think the first step would be do some experiments, creating a set that is large enough to be used as a training set as well as a validation set.
Is it then not a better approach that for every chemical that is produced, and you need these, because also biodegradation tests need to be done for a lot of compounds, that you do similar tests for all the compounds that are produced? Is that not an easier approach and a safer approach?
Well, my opinion is that once you would have, say, 100 empirical data, then perhaps you don't need to test them anymore, because you can use that particular set for trying to derive that QSAR. And if the QSAR that comes out of that is then within, say, pre-selected boundaries of statistical quality, I think you can move on without doing additional empirical tests. But if, as long as you don't have them, you cannot simply derive any relationship. So that's obvious.
It's a little bit close to this question, because you did now a test with 150 plus samples, and I was wondering, in order to be statistical safe, how many samples would you be needing to do an analysis like this? Can you already do it with 50, or do you need 100, or 150, or can you give an estimation?
Yeah, it depends a little on the chemicals, because if you use, like, say, 20 very similar chemicals, which only some structural groups are different, then you can make a good prediction for that particular group, but not for all other chemicals. So I think if you need to have a complete range, or as wide as possible, then you need a few hundred in that order.
It's a nice applicability of chemical space.
Yeah, to have the wide chemical space.
Yeah, because otherwise, because there was also a question I thought of. If you talked about that compounds have to be within a certain leverage, and if they are out of your boundaries of leverage, shouldn't you be looking at different descriptors? Did you not choose your descriptors right, or?
Yeah, of course you can try other descriptors, and maybe that will change. But then maybe the prediction of your QSAR will be less good.
Yeah, but you discard them anyway because they're out of your leverage. So how it's rather that they disrupt your model.
Yeah, they
then
just,
that they add to the quality of your model.
yeah, that's true. Yeah, or it can be the other way, because they have a big influence, and they make statistical parameters of the model better.
Okay, yeah, I understand.
So it can be both ways.
Yeah, okay.
I'm Erik Baars from Waternet. I've got one question for Pim and one for Minne. The first one is about this sewer epidemiological approach. You put it on the sewers, but first you started with the River Meuse and the River Rhine. I think you can have this approach also on the River Rhine and the Meuse, because you said the River Rhine has a bigger liters per second, so that will make the difference. I think the total catchment area and all the sewers can make also the difference. So if you go to that figure and you put it on the people and all the sewers coming in the River Rhine and River Meuse, I was interested how much the load will be per habitat. Understand what I mean?
Mm-hmm.
Yes.
Yeah, I think basically you're right, because whenever you take a sample somewhere in the river basin, you will obviously have a reflection of everything that has been put into the river before that point.
And because I was wondering if the Belgians use less drugs than the French and the German people, because that was my... I couldn't see it on the graphs. It looked like the River Rhine had a bigger load, but I don't know if the load is bigger per habitat, per person.
Yeah, I don't have the numbers by heart, to be frank. But I think the overall number of people upstream of the river, upstream the River Rhine, upstream of Lobit, is much higher than the number of people upstream IJsden. Not only because of the length of the river basin, but also because of the population density along that river basin, I think. So in terms of loads, it's not surprising to see that the River Rhine is much higher, both in absolute amounts as well as in of course, the flow rate.
Okay, and just a final question about the comparison with the rural and the urban area.
Mm-hmm.
I think there can be a problem with the rural area if they are not using the toilets. You understand what I mean? Sometimes in the weekend they go to a caravan or they go to their own place, have their party, and I don't think they use the toilets where you are looking for.
Yeah, that's true. And you can think of specific party houses where big parties are being held and which are quite likely to be using quite large numbers of or a large amount of drugs during those parties. If those farm houses are not connected to the sewer system, we will obviously miss them.
Yeah.
But I could say to the contrary. For instance, if we monitor a certain area where a big party is being held, we can actually observe that one day later in the sewer of that particular area, we can indeed observe a large increase of certain drugs of abuse, like ecstasy, just as a result of the party being held.
Very
and
nice.
in fact, you have to account for that in such weak monitors as I showed, because it's quite obvious that during certain weekends you don't have let's say the normal increase of a weekend use that is observed normally in almost every town. For instance, for cocaine, if you have a specific party with say several thousands of people being present, then you might have an additional amount on top of the normal weekend rate.
And Minna, I have some question especially about the no effect, because you are starting with the food, with this TTC, and you're going to some level where you say there's no effect, but the level is not zero. So somewhere you put in an acceptable level, because impeccable is only possible if the chemical was not made. You understand what I mean? So I'm thinking about pathogens. They have a 10-4 risk. I was wondering if there's some 10- whatever risk in this pesticide approach.
Well, that goes down to some basis of toxicology. where we have two kinds of compounds. The genotoxic compounds, they are assumed that there's no level that's safe. Even one molecule can give an effect. But other compounds, they are typically known to have a threshold where they give an effect, and below that they do not. They can even be beneficial for you. Like vitamin D is very, 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 very beneficial for you at low doses. But there is a dose where it becomes toxic. And there are numerous examples of that. So for most compounds, not the genotoxic compounds, there is a level where really you don't have any toxicological effect, because the body can handle the compound. It has detoxification systems and can get rid of the compound. So the balance is not disturbed. So it's really no effect then.
Any other questions?
Maybe a question to Pim. It's very nice with your sewer epidemiology to see where drugs are used. Have authorities, health authorities or health agencies already shown interest in your approach to find better ways to identify spots where they are used?
Yeah, the answer is yes, although it's going slowly, I should say. In my last slide, I showed the EMCDDA, which is the European Monitoring Center for Drugs and Drug Addiction. So that's an EU agency responsible for monitoring the use and consumption within the entire European Union. And they have actually supported this 19-city comparison study. So they have taken the opinion that the use of sewer epidemiology from chemical data is actually a very nice complementary source of information to say what used to be their regular work, which is drafting inventories, questionnaires, trying to do calculations based on what is available on the internet, based on what is available from police raids and so on. And in fact it turns out, and we as chemists like to advocate that this method that we propose is probably even better from a say a robustness or reliability point of view than maybe inventories and questionnaires. So yes, there is a definite interest in legal authorities. Insofar as the Dutch authorities are concerned, I think now that we have produced this report from RIVM and KWR in June, I think it was, I think the interest is raising, and we plan to have a stakeholder meeting within a couple of months, where we will specifically invite stakeholders such as the ones you mentioned. Okay. Yeah. Including, for instance, health services, GGDs, and so on.
Those are health organizations. What about our Netherlands Forensic Institute, our CSI?
Yeah, well, we have obviously informed them about this work, and they are very well aware of this work. I haven't seen a reaction yet on this specific report that I referred to, but they will probably also be one of the stakeholders interested in that meeting that I'm announcing. I'm quite sure that they, of course, they are interested in drug analysis in general, but until the sewer epidemiology came up, most of the work was in like testing quality of drugs, testing when a certain rate recovered drugs from smuggling or whatever, in order to see what kind of drugs they were, and not so much in the low concentration analysis that we're referring to here. So the type of work that the Forensic Institute performed was quite different from the work we have presented here. And now that we have actually shown that you can use it in such a way, and I'm saying we, but that means the entire group of scientists working on sewer epidemiology, obviously. I think it's perceived as a very nicely appreciated complementary tool to the work institutes like the NFI are doing. Yeah.
I also have a question to Dr. Salman. It was not in your presentation, but it was in your paper, and you didn't show it, but you did quite a large. You test on quite a large range of different pH, from 2 to 12.
Yeah.
And I was wondering what was the background of this large pH range, and not choosing it a little bit smaller.
Actually, I'm sorry, I'm not mentioning in my presentation to this issue. Yeah, I checked the effect of initial concentration of carbofuran solution, and also I checked the effect of the change of pH from 2 to 12. I studied the effect of change the pH solution with the absorption capacity. Actually, it is available in my paper, but not available here in these slides. But we saw that the absorption capacity for carbofuran decreased with increasing the pH solution. Yeah.
And did you find the most optimal pH? Or
Yeah. Actually, the optimum it is around 6 pH. The optimum for absorption capacity. Yeah. Thank you.
I have a last question to Mr. Temming. I was wondering how you excuse me, how you did your selection of compounds. Was it based on the probability of occurrence, or did you do it on certain compound properties, like Bas looks for in his selection of?
Like everything. So it's the use and some mechanisms that we suspected could influence removal. All these items we included. But we also, I have to admit, we looked at the possibilities to actually analyze them. Because from my past, I know that you can start off with a long list of chemicals, but you have to reduce it because of the texture limits, etc. Yeah.
And did you have any problems with people agreeing? Because it's quite a small group for.
Not at all.
Not at all.
Not at all. No, because I think they also live there because they believe more or less in this approach that we have. So they knew in advance that there were going to be tests. Yeah.
And what is your prediction when you want to test drugs of abuse?
For these 32 houses, no prediction from my side. Sorry, that is confidential.
Any more questions?
Recommendation I want to share because of the QSARs, the drugs of abuse, and of the emerging contaminants. The surface water treatment plants in the Netherlands, PWN, Dinea, and Waternet, they do every 5 years a test in a pilot plant with a cocktail of these, let's say, worst boys, and put it in a pilot plant, because then you can lower the influence and you can look what happens through your scheme of ozone, UV, or whatever you have. So we do that every 5 years, and it's based on what they will find for the most difficult, most worst boys of these emerging contaminants. I would like to share with you that. Okay? Thank you.
Then with that last question, I want to thank our presenters once again for their contribution. And maybe some final closing remarks. I was really glad to see in this session how a nice balance between all the different aspects concerning compounds, from appearance in the water cycle, the targets for our drinking water production, and also the prediction of different removal rates by properties of the compounds. It was really nice to see. It was also nice to see that in Iraq you use local produced activated carbon from the palm oil front. Because, for instance, I heard in one of our other sessions on sustainable water solutions that, for instance, activated carbon in Spain is being regenerated actually here in the Netherlands, and it's one of their largest contributions to their climate footprint. So it's really nice to see that other materials like this are also very well suited and being researched. I was also doing some calculation myself, so I thought, well, 1200 milligram per 1,000 inhabitants. And that's if you have if you make 3 to 10 lines from this cocaine, and then you can get it from about 1 gram. It's not these thick lines that you showed on your report. So for starting use, maybe 10. It is all Wikipedia knowledge. And then you have half weekend users and half regular users here in Amsterdam. So that gave me about 1 in every 250 people in Amsterdam are cocaine users. So I was thinking I have a department of 300 people, so there should be 1 user, but well, luckily I live in Amersfoort and it's very close to Apeldoorn, so there are no any worries there. With that last remark, I'd like to close the session, and you're all invited to have some coffee or tea in the lounge. We'll see you back at half an hour. Thank you.